Okay, let's do some review here. If a wooden block slides down an incline at a constant velocity, so the key word here is constant velocity, which means forces are balanced. The force of friction must be equal to the force perpendicular to the incline. No. Force parallel to the incline. Yes. B, right? Which way is friction going to be? Right there. That one there and that one there would have to be equal to each other, right? And that way the net force down the incline would be 0, correct? Number 2. An empty wooden crate is slid across the warehouse floor. If the crate were filled, the coefficient of kinetic friction between the crate and the floor, it's not really a trick question, but the correct answer is C.
Well, that was a trick question.
Well, it is a little bit. It's not a trick, it's a question designed to see if you really understand.
That was tricky.
Mu is only dependent on one thing. How rough the surfaces are. Okay? It's only dependent upon how rough the surfaces are. So, when you put something in that crate, remember mu is Ff over Fn. So if I fill up that crate, what am I increasing? I'm increasing the weight force considerably, which means that the normal force increases, but because mu is only dependent upon the surfaces, like wood on concrete or what have you, right? So because this must stay the same, what also has to go up? The friction force, right? So if the normal force before was, say, 50, and it goes to 200, and the friction force before was, say, 10, what would the new friction force be? If I went from 50 to 200 on my normal force, times by 4, the friction force would increase. So it's the friction force that increases, but the coefficient remains the same. The coefficient is simply how rough the surfaces are. I'm looking for nods of understanding. Number 3. An empty wooden crate is slid across the warehouse floor. If the crate were filled, the force of kinetic friction between the crate and the floor. Well, now we know the correct answer is, what would happen to the force of friction? That would increase. The force increases because the coefficient stays the same.
This is where it all goes.
Well, let's try to flatten that out. A 5 Newton block with a surface area A is dragged across a horizontal wooden table and experiences a friction force of 2. What is the friction force acting on the 5 Newton block when the surface area is increased to twice the area? Hopefully you remembered that friction is independent of area. In other words, the friction force remains the same. Friction force remains the same. The pressure changes, but the friction force remains the same.
So,
friction does not depend upon area. Which pair of quantities could be used to determine the coefficient of friction for granite on concrete? Would it be the mass and speed of the block, mass and normal force in the block, frictional force and speed, or friction force and normal force? Well, mu is always Ff over Fn, which is D. And yay, most people got that right.
Isn't that a big block of weed? Isn't that rock like a big block of weed?
I wouldn't know what that looks like.
That's what it looks like.
Haven't you ever like watched Miami Vice?
I suppose. Miami Vice, the original. Yeah, the 80s version. The net force required to start an object sliding across the uniform horizontal surface is larger than the force required to keep the constant sliding at constant velocity. These forces are different because the force of kinetic friction is greater than the force of static friction, decreases as the speed of the object relative to the surface increases as the speed of the object relative to the surface increases, or is less than the force of static friction. And unfortunately, how do we do? Maybe I shouldn't say unfortunately. We didn't do so good.
8.
Kinetic friction is always less than static friction. Kinetic is always less. So A is definitely wrong. Kinetic friction decreases the speed of the object relative to the surface increases? No, not true, not true. Kinetic is less than static. That's what it boiled down to there.
And this is like right
A 50 Newton horizontal force is needed to keep an object weighing 500 newtons moving at a constant velocity of 2 meters per second. The magnitude of the friction force acting on the object is, oh, I've asked this question before. If you have to apply 50 newtons to move it at a constant velocity of 2, does it matter what the constant velocity is? No. What's the friction force? Minus 50. Well, I guess it would be D would be the best answer. But how do we do? Well, not bad. I'd rather see all D. Right? No A, B, and C there.
Which one? Which one is that?
That's number 7.
Oh,
Right?
I got that one.
Constant. Did you know it or did you guess?
I just guessed.
Don't guess. Know it. Do you know it now, Lucas? Do you know why now, Lucas?
No.
No? Still no?
No.
Why not, man? I just explained
I
it.
still don't get it.
There is an applied force of 50 newtons, and the velocity is constant.
Whatever's constant.
Forces must be balanced. The net force is 0, which means that one has to be exactly opposite that one.
I know it. I know it. I learned something.
A 20 Newton block slides over a horizontal table. If it takes a force of 5 newtons to move the force at a constant velocity, what is the force of kinetic friction on the block? Isn't this the same thing?
Yeah.
Isn't this exactly the same question? I hope the answer is B. Oh, you got it right that time.
I got that one wrong, actually.
You got the first one right, but you got this one
Because
wrong.
I told you, I guess I didn't know what I was doing.
Do you understand it now?
Oh, yeah.
What's different about this question, Sam? Exactly. You're looking for coefficient. You're looking for
It's not going to be the same answer.
mu, Ff over Fn. If it takes 5 newtons to move the block at a constant velocity, what is the friction force? 5. And it's 20 Newton block. That's your weight force. So your normal force is also 20. Your answer, 0.25. These questions are all ones you should be able to do. There's no sneakiness involved at all. I'm not asking you anything that I haven't talked about. What are you talking about?
Number 2, whatever it was.
Well, it may have been a little bit misleading, but I'm reminding you of that. You should have known that. I'm just reminding you of that. So, okay, so that's about all I got for you today. I strongly urge you, do some problems. I know there's only 30 minutes left. I know it's Friday. I'm here to help. Nate has found the checklist. So a reminder that at the start of the unit, I gave you this, topic 4.1, gravitational field study checklist. You know what? How about we go through that, Nate? And let's see if we know all that stuff. Here's the checklist. Here's what's on the test. Woo! Define the gravitational field qualitatively as the region of space around a mass where another point mass experiences force. In other words, you should know what a gravitational field is. It's the space around an object where another object experiences a force.
I know what that is.
Actually, gravitational field.
Diagram the Earth's gravitational field using lines of force. So what I'm talking about is this picture here.
Do that.
You guys feel the drawback?
Remembering that the closer the lines are together, the stronger they are.
You mean the closer they are to the center?
No, I mean the closer they are to each other, like here. Remember how close they are there compared to there?
Okay.
Right?
So the closer,
We talked about that.
the closer, the stronger, right?
Yeah. define the gravitational field quantitatively as a force per unit mass. In other words, yeah, I mean, am I going to ask you, what is the gravitational field quantitatively? No. I'm going to expect you to know that it's 9.8 newtons per kilogram. For every kilogram of mass, it goes up by 9.8 newtons. Compare and contrast terms mass and weight. Well, the mass is a measure of how much there is, how much stuff, and weight how much gravity pulls on it, right?
I'm pretty smart.
Well, because I taught you all this,
I
right?
knew the first 4 things.
Not that you weren't smart before.
I knew the first 4 things.
What's the difference mass and weight?
That's like 40%.
Mass is how much there is, and weight is
Weight
how
is
much
the-
gravity pulls on
Your weight, your mass can change your weight.
it. That's about all I learned.
Did I describe qualitatively and quantitatively apparent weight changes in vertically accelerating systems? Did we talk about guys and girls losing weight and gaining weight on elevators?
Yeah.
Yep.
At the bottom, you're fatter than when you're at the top.
Well, oh, that's a poor one.
Why is that?
Remember we spent like a couple days talking about the elevator at the bottom, right? And then it accelerates up, and your weight force is more at the bottom, and then when you're here at the top, it's
Less.
less.
Because you're
And we did problems like that. I know we did. No, because you're accelerating up and down. If you're just sitting there, you weigh the same. It's when you are accelerating, vertically accelerating. Derive the acceleration due to gravity from free fall and Newton's laws. Well, gravity is 9.8. Really, that's what you got to come up with, right? Did we perform an experiment to calculate G near the surface of the Earth? We did. We dropped my brand new G balls and we calculated that. Did we solve free fall problems? Certainly. Over and over and over again. To the point of nauseam.
We have, like, are they all kind of mumbo jumbo between the forces, like velocity and all those different formulas?
Yes.
Meet them all?
Yes.
How much the test in theory now?
Oh, well, you know, most are. Yeah.
A lot of formulas.
Describe terminal velocity. Do you know what that means?
Certain points
We've talked about it. It means what?
where
When you are no longer accelerating. How come?
Oh.
Because the weight force is equal to the
Thermal force.
force of air resistance.
That one. It was that one.
Terminal velocity, Lucas, right? So, weight force is force of gravity is the same as the force of the air resistance force, right? And when those two things are balanced, then your net force is equal to 0 and you no longer accelerate, right? Did we define the coefficient of friction as the ratio of the force of friction and the normal force? Did I give you the formula FF over Fn? You betcha I did.
Yeah, because I got it right on here. You are. I was already written there.
Did I distinguish between static and kinetic friction? I just talked about that today.
Hey, they're kind of confused here. I'm just making a little bit of, you know.
Yeah.
Static is at rest, kinetic is
Emotion.
in motion. Static is always greater than or equal to kinetic.
Okay.
Right?
What? Always.
Always greater than or equal to the kinetic.
Ooh.
Yeah, put it under there. I won't see it.
My dad called me, so.
Yeah?
You better.
Tell him you're busy reviewing physics.
You should actually have a
He's like, what is this?
No, it's too bad. I don't want to. I'll let him talk to you if he calls you again.
Okay. I won't be too much longer. You can probably answer in a couple minutes.
He's gonna do that.
What?
He's gonna do that.
Who? I would be. I was like, you can't talk to Lucas right now because I want him. I'm pretty scared. I see what he's
Compare the effects of the normal force, materials involved, surface area, and speed on the force of friction. We did that in that review today, did we not? I talked about what happens when the area changes, right? We talked about the speed.
Talk about it again.
No, I just did it today.
Why don't we do it again?
I talked about it today. It was in that little quiz.
Alright.
Did we solve problems with the coefficient of friction for objects on a horizontal surface? You betcha I did. 12th.
Well,
I think I covered everything.
yeah, but really quickly, like you were around.
Did I do any extra?
No.
Yeah, I need a little bit extra.
Like what?
All this is extra for me.
The only thing that I may have added in is that little bit about pressure
But it doesn't matter if you put
and the
all-
bed of nails and stuff like that.
Is it okay to go answer this?